for A1. Right. This is our angle. S1 is equal to X. Okay. This is S1. Okay. And we have AB that's parallel to SP. So A1 is alternate to angle S1. So here we'll say, okay, let me write it like this. Angle A1 is equal to angle S1. They are both equal to X, but they are alternate angles. Okay? And you must take the lines that are parallel, that's AB is parallel to SP. Okay, so I hope that you saw that. Then the second one is a little bit tricky. Like the way that I'll do it is this. If you look at the circle, okay, there are there are about 5 vertices of that shape, which means it's not a cyclic part. That is R, B, A, T, Q. But the good thing is point R, point B, point A, and point T, they form a cyclic quad, which means angle A1 is going to be an exterior angle of a cyclic quad. So it's equal to angle R1. I hope you saw that. So we can write here and say R1 is equal to angle A1. They are both equal to X. You're using exterior angle of cyclic quad. Okay. Is there anyone who found any other angle besides, other angle besides these two? Did you manage to see both of them? Okay. So let's move on to the next question. Now the next question is on similar triangles now. Okay? So we need to prove that PTS is similar to PSR. Okay? Just to indicate which our angles are, we have got P, okay, TS, that's the angle, the triangle there. And then we have PSR, that's PSR. Those are the two triangles. Right? You can see that they share a common angle. And that common angle, we can see it in the name. Okay? That makes things easy. Okay? So we'll just write here, number 1. Angle P. Okay, that will be P1. Okay, it's wiser for you to specify which P there. If you write P only, it's not entirely correct. Which P? It's P1. No, it's not P2. It's P1. P1 is common. Is that a 2? Oh, I'm seeing, no, from my angle, I'm seeing it like it's a 1. Okay, it's P2, right? Then, let's look at what else we have. Now, in most cases, these questions, they've got a connection with the first one. Okay? So, we have got T, which is, in that case for PTS, is this angle. Right? We don't know anything about it as yet. And then angle S, which is this whole angle. We don't know anything about it. Okay? But angle S for PTS, angle S, we're talking about S1. And angle R, we're talking about the bigger one. We have proved that those two are what? Are equal, right? So we have proved it here. Okay? So since A1 is equal to S1 and R1 is equal to angle A, I'll just write this as it will be S1 is equal to R. It's R what? Is it R1 or 2? Okay, let me check on the original diagram. Oh, it's R1. It's R1. I'll just say proved in what? 6.1. Okay? If you want, you can rewrite what you wrote here. What you wrote, and then say, therefore, R1 is equal to A1, if you want. Okay? But it's proved there. Then, the third pair is very easy. So you just say, so we got PS, then we need angle T. Okay, that's angle T. It's T what? It's not specified what T. T2. Am I right? Yes. So, but the T2, right here, T2 will be equal to angle S. This will be based on sum of angles in a triangle. Therefore, please take note that here the order is not there. The order starts with P, then T, then S. So when you write, make sure you follow the correct order. So it will be triangle PTS is similar to triangle PSR. Then you write your triple A. Okay. So proving that triangles are similar should not be a big problem. Right? Then let's move on to the next one. Any question? Right. The next one. Right. So let's look at it. I hope you did the question on your own. Okay, so we have triangle PQT. That's P, Q, and then T there. And then PRQ. Okay, P, R, Q. They have a common angle. You see that they have a common angle, which means we are almost 50% there. So, one is we are supposed to write it properly in triangle PQT and triangle PRQ. Okay, then you write here our angle P1. Angle P1 is common. Okay. Then if you look at the question, PQ is a tangent. So Q1 is equal to R2. Okay. Q1 is equal to what? R2. So I'll write it here. Angle Q1 is equal to R2. And that's tan chord theorem. You see that? Yes. Then the third pair would be easy. So we have got T. But the way you write the T now, it's T1. Okay? So angle T1 will be equal to Q. Okay? The Q is the whole angle. That is Q1, QQ1 plus Q2. So I'm just going to write it as Q. Okay? So that's sum of angles in a triangle. Therefore, triangle PQT is similar to triangle PRQ. That's triple A. Okay. I hope you were able to do that as well. All right. Now, in most cases, if you prove that triangles are similar, you might need to use that in the next questions. Okay. So when you are proving that triangles are similar, please, from now on, you don't need to get scared. If you prove that two pairs of corresponding angles are equal, then you are done. The third pair is based on sum of angles in a triangle. It becomes even easier if you have a common angle. If you have got a common angle, then it means the question is even easier to do. All right? Then let's move on to the next one. It will be PQ over PR is equal to PQ over PR is equal to QT over RQ. So that's QT over RQ. That's equal to PT over PQ. PT over PQ. The reason those two triangles are similar, so that's triangle PQT, and triangle PRQ. Okay. So I'm almost there. Like, what am I looking for? I need PQ, so I put PQ there. Okay, I put PR. I've got another PQ here, and I've got a PT there. So I can say, therefore, PQ over PR is equal to PT over PQ. Then I'll cross multiply. So I'll get PQ squared is equal to PR times PT. And then you're done. Okay, in actual fact, to be honest with you, a question like this one, I don't consider it to be a grade 12 question. Okay, because the concept of similar triangle did in grade 8 and 9. Okay, when you get here, it's not grade 12. That's my opinion. Okay, because once you prove that triangles are similar based on corresponding angles, means the ratios of their corresponding sides will also be in proportion. That's from grade 8 and 9. Okay, then the last one. So, if I write PT over PS is equal to TS over SR, that's also equal to PS, okay, over PR. And that is because those two triangles are similar, and I have proved that. Right. I want you to be aware that this last question requires a bit of some thinking. Okay, it's not so straightforward. So you have to decide how you are going to approach it. Okay, so I'm going to use the first pair of similar triangles. Right. Remember, I want PS. Don't forget that. I want to prove that PS is equal to what? To PQ. Okay, so in this equation, I need that PS. I need that PS. Okay, so I'm going to choose these two. So I can go and write, therefore, PT times PR is equal to PS squared. Okay, and remember here I can start with PR. Yeah, it's the same thing. PT times PR is the same as PR times what? PT. Now, if you look at the previous question, we have got PQ squared equal to PR times PT. Okay? So I can write this part. PQ squared is equal to PR times PT. Therefore, PQ squared. I hope you can see that the left-hand side here is the same as the right-hand side there. So I can insert the two. If I do that, I'll get PS squared. Okay? Which means, since they are both squared, it means their square roots are what? Are equal. Okay. How did you do it? Same way. Exactly the same way. Is there anybody else who approach in a different way?